Hey guys, welcome back to Data Products. In this lecture, we're going to be going over QQ plots, which stands for quantile-quantile plots. And this is a probability plot, which is a method for comparing two different probability distributions by plotting their quantiles against each other. And so this is a way that we can look at data and see if it comes from a normal distribution. So this starts to bleed a little bit into our preliminary data analysis. Because we need to know the quote-unquote shape of our data, whether it's normally distributed, non-normally distributed, skewed, etc., before we can do the proper graphing and statistics to it that we need to tell our story. So let's get into it with these QQ plots. Okay, first things first, let's open up our studio. Oh, I have my run-through of the QQ plot code here. Alright, new file, our markdown. We're going to do QQ plots. We'll leave it as an HTML file. Alright, get rid of this jazz again. Alright, first things first, let's kind of annotate. Now let's take a look at QQ plots. These are used to determine if the given data follows a normal distribution. Okay. So let's start by doing install packages, and we're going to install ggpub-r. You may already have it installed. I'm going to hash it out because I know I have it installed. But if you don't, that's how you install it. And then we're going to set our seed again. So setting our seed, remember this is the way that we make random distributions that are repeatable, right? Or random numbers that are repeatable. Because we're going to create random normal and non-normal distributions. Okay, so now let's do, oops, what did I do here? Okay, now let's randomly generate some data. Alright, so we're going to call this just something wdata equals the data frame. And in that data frame, we're going to say sex equals a factor, rep, C, female, male, and then each equals 200. So this is just going to be like our previously created, if you did my other lectures, that is, where we're creating 200 randomly generated weights in kilograms for males and females. So 255 is going to be our median or average weight, mean weight for a distribution for females. And then for males, we're going to have 200 observations randomly generated with the average being 58. And so let's run this. Last time I had a problem where I had a third column or something going on, so we've seemed to have avoided that this time. Okay. So let's set our theme for graphing with ggplot. So what am I going with this time? So first of all, let's call ggplot2 because we're going to be using that. And then let's do theme. Oops. Theme set. Theme classic. And then theme legend. Position equals, I like top for this plot. But again, just like my other videos, you do what you want to do because there's no correct way. It's kind of a, whatever you think is best. All right, so let's create a QQ plot of the weight. All right, so we're gonna do ggplot. wdata, our aesthetic, is going to be our sample being weight, and we're going to call statQQ, which is the type of plot, our aesthetic's going to be color equals sex. So we'll have two lines based on sex. It'll divide our data into two. Scale, color, manual. You can pick whatever you want. I seem to have always used these ugly colors, but I'm going to stick with it. It's become a meme now at this point. So mine are, let's see, hashtag 0073 C2FF, and then the other one is hashtag FC4E07. I think that's probably my mustard and blue. Let's see, what is that? Oops, I need a plus sign. And then our labels. Y we're going to say is equal to weight. Okay, so let's run this and hope it works. It does. Okay, so here's our QQ plot. So what you kind of want is a slope of 1, right? So for every 1 you go over, you go up 1. And that would indicate a normal distribution. So this is pretty normally distributed. There is, because we're doing random data generation from a normal distribution, you get a little bit of kind of wiggle or deviance in these tails here, but this is a really good QQ plot. And it makes sense because we used a function that specifically takes data from a normal distribution. All right, so let's try this one other way. There is another package that makes really nice ones. So if you don't have it installed, it's install packages ggpub-r. I'm not going to run that because I already installed. We're going to do ggqq plot. Oops, I actually have to run the library first. Library. Let me scroll down so you can see. Library ggpub-r. Then we're going to do ggqq plot. wdata. X equals weight. Color equals sex. Palette equals, I'm just going to copy this. Oops. Oh, I noticed now that I'm looking at it, I used red and blue and it wasn't mustard and blue, light blue. So I changed it up when I was writing this. And then gg theme equals theme pub clean. And that should be it. So let's run this guy. And so as you can see here, you have a QQ plot. You have kind of the what is considered acceptable error within this QQ plot. That's the kind of error bars or the shadowing that goes over it. And then you have our line of the normal distribution there, which is great. And so that is how you do QQ plots. But before we end, I want to show what it's nice to have good looking data, but what would bad looking data be like? Now what would a non-normal distribution look like? So we're going to install another package. Let me hash this out actually because I've got it installed. Packages, and it is mnon-r. So we're going to call the library for this mnon-r. And our data 2, we're going to call it, is mnon-r mnon-r after the colon. Our number, we're going to have 1,000. P equals 2, so we're going to create 2 different distributions. We're only going to use one. MS equals 3. MK equals 61. You don't have to worry about this. Is just some of the variables I found to make a very good drastic non-distribution. We're not going to get into all the stuff for skewedness. 0.5, 1, 2, 2. This is just so you have the data. I'm not so worried about you learning how to make non-normal distributions yourself. If you are interested in that, just check out the help on the m-non-r package. Okay, and then data 2 as data frame data 2. I hope you can read that. So we have m-non-r : m-non-r, and then that's our function. So we're gonna within there we're gonna call n equals 1,000, p equals 2, ms equals 3, mk equals 61. Our sigma is a matrix which has a collection of these values 1, 0.5, 0.5, 1, and then it's a 2 by 2 matrix, or 2 by 2 on top of that, and then initial equals null. Okay. Yeah, so it is a 2 by 2 matrix, sorry. Okay, so now we have data 2. So if we look at data 2, we have two variables because for some reason when I tried to run this with 1, it didn't work. So we have column 1, v1, and v2, and these are all just random numbers from a non-normal distribution. So now that we've got that, now let's plot the non-normal data. Let's see what that looks like. So you know, if you do, because that's one of the things I noticed ggplot a lot with when you learn how to do stuff like QQ plots or doing principal component analysis or these different statistical methods, it tells you like this is how you do it, but then it never shows you like what a bad one is and what a good one is. Like you have an example of a good one a lot of times, but never a bad one. So I want to show you what a bad one is. So if you see a bad one, you can be like, okay, now I know my data is not normally distributed. Okay, so we're just going to do ggplot data 2. Our aesthetic is we're going to do sample 1. You can pick sample 1 or sample 2. And then we're going to do stat QQ. All right, so this is going to be the real basic one. And as you can see, it's all squiggly, sigmoidal almost, right? And so there's no, if you were to draw a straight line through it, it would not match this plot. So let's do the second method for the same data that has our nice like error region and our confidence interval and our line drawn through it. So let's do ggqq plot of data 2 AES, oops, sorry, no, x equals v1 palette. We only need one because we're doing, so I'm just gonna pick one of these. You can write Indian red or whatever you want for your color you're gonna use. I'm just gonna pick this guy to keep it in line. And then we're going to do gg theme equals theme pub theme. That's it. And let's hope this works. There we go. So you can see we've got our confidence interval. Our colors didn't really show up. Maybe it's because I only have one color. Anyways, so you can see that this is what our expected, our data, if it was normally distributed, would fit this line here, and our stuff is way off. So if you compare it back to these, you see these are very nice QQ plots where they fit the normal distribution. This one, this would be our expected data, or theoretical, so to speak, and this is our sample where they are, so it's like all over the place. So that is generally it. That is how you do QQ plots. That's how you graph data and determine if it's normally distributed or not normally distributed. And this is a way too to kind of detect outliers. So if you have like a couple points that are not on a line, but the majority are, then you can kind of see outliers that way. We'll actually get into statistical tests for outliers in the next couple of videos, so we'll be able to actually pick out the outliers themselves based on statistical tests, but you can eyeball them too and identify them with these QQ plots. Look at that, right on the 15 minutes, right where I want to be. So with that, if you're watching on YouTube, hit subscribe. If not, class people, I'm sorry to be, shilling my videos so much. You're probably getting sick of me saying click subscribe. But anyways, I hope you like this video. If you are interested, there'll be many more graphic videos, there's going to be Python videos, a whole bunch of stuff coming to the channel. So check out my other videos, and I'll catch you in the next one.